In this video, I'm going to explain how to do questions that relate to Newton's second law. So on page 350 of your textbook, at the bottom of the page under Math Skills, you'll see this problem. Zookeepers lift a stretcher that holds a sedated lion. The total mass of the lion and the stretcher is 175 kilograms, and the upward acceleration of the lion and the stretcher is 0.657 meters per second squared. What is the unbalanced force necessary to produce this acceleration of the lion and the stretcher? So we set up our data table. What are we given? We're given the mass of the lion and the stretcher is 175 kilograms. And we're told that the acceleration of the lion and the stretcher is 657 meters per second. So that means, again, that every second, the speed of that apparatus increases by 0.657 meters per second. So how much force do we need to create that acceleration? So our formula for Newton's second law is just F equals ma. It's probably one that you've heard before, but if not, no worries. So we have our data table, we have our formula, and now we can substitute or plug and chug. Okay, the mass goes here, 175 kilograms. Remember, kilogram is the SI unit for force, so we don't need to convert that. It's totally fine. If you're given the mass in grams, you do need to divide by 1,000 to get kilograms. Our acceleration is 0.657 meters per second, or meters per second squared. And then when we multiply those together, we get the force is equal to 115 kilograms meters per second squared. And so I want to talk a little bit about this unit here. This big unit, kilogram times a meter per second squared, is a Newton. And that's the unit that we use for force. So we just say 115 newtons. And technically, since we're lifting it up and forces do have direction, the force is 115 newtons up. So that should allow you to do the three problems on page 351. Let's break down the formula so that you can have it depending, no matter what they ask for. So if we start with F equals ma and we divide and we say, well, what if I asked for acceleration? Well, if I divide both sides by m, then I get acceleration equals F over m. So you can call that your second formula. If we start with F equals ma and I say, well, what if I ask you for the mass? We divide both sides by acceleration, and we get mass is equal to force over acceleration, and then we have F equals ma. So again, there's our three formulas. If you have the data table written out, it should be fairly simple. Solutions to these problems are posted on Canvas, and if you have any other questions, let us know.